changes anything.
Okay.
Okay, now try looking. Like, try refreshing.
Okay. Oh, I see test stream. Juvix first impressions. Blah 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 blah. Let me click that.
All right.
Cool.
So if that works, you
Oh,
can view my stream. It's you might have to mute that stream
oh,
because yeah, you might get
oh
like
gosh, yes, it's so confusing. I'm hearing myself from the past.
oh, okay.
Oh God, how do I mute the stream?
I think you can click on the little like speaker phone button, or you can close the stream. Either way. Just wanted to test that.
Okay, I closed the stream. Oh, just one sec. Hyun is coming. Hey,
Oh,
sweetie,
okay.
I'm just on a test call with Jonathan. Just give me a minute, okay?
All right. Cool stuff.
Okay. So that appears to work just fine. So I can hear myself, I can hear you, I can see your pardon me, I can see your desktop. Yeah, it seems to be working pretty well.
Oh, you can see my desktop right now.
Oh no, when I was watching the stream.
Oh, when you're watching the stream, okay. So if I like share it in Discord, let's see. Actually, let's test that to make sure that works too.
Okay. Going back to
Uh,
Discord.
I'm gonna share my full screen. Go live. I don't know if this is a good idea. We're gonna try it.
Okay, let's see what we can do.
We're gonna try it. We're gonna see if I have utterly destroyed my computer.
Let me see. I'm looking for the join stream button. I
Oh,
heard the sound,
yeah.
but I don't see the
It should have started.
where is it? Uh, hmm.
Roro.
No, I think this is just me not really knowing how to navigate to the stream in the phone interface. Stream. It says you're streaming a game,
I'm not
so
streaming a game.
oh well, that's what it says you're doing.
I'm streaming my desktop. That's all.
Why can't I join your stream? This is weird. Profile. Nope. Just streaming a game. Okay. Oh, here we go. Join stream.
All right.
Whoa.
Is it
Okay.
is it like really laggy or something?
No, it put me into this view where I could see my icon, your icon, and your stream. So I just
Oh,
double clicked on the stream, and now I'm just looking at the stream. It looks pretty good to me.
okay, cool. Yeah. So
Yeah.
you
Juvix.
did
Hi,
you want to
Jonathan.
did you want to hang out for a bit and do like a
Sure.
short little stream?
Yeah, sure. Do we can do a short little stream.
All right. Cool. So yeah, what I was doing today was I was just checking out Juvix. So uh, I have all the info about it here. Essentially, I've signed up for their mailing list just so I could be informed about the project. And this is basically what they said. They've announced this new Dactylobiotus release, which is like a pre-alpha release for their programming language Juvix, and it compiles to Michelson. It's some
Which Michelson?
so I don't know what that is exactly. It's some programming language I think for like crypto stuff. I don't know. So like background, I don't know anything about crypto. I'm just interested in the
Okay.
project purely from the perspective of it's a programming language with dependent types, and that's kind of cool. But yeah, I
Could you
don't know
remind me what
anything.
dependent types are again? I know you've already told me this, but I forgot.
It's like when you have first class types, so you can treat like types as values and stuff. I'll be showing off a little bit of it I think today.
Right. Okay.
But essentially, yeah, this is a dependently typed language, kind of like Idris and Agda and other such languages. It's a new one, of course, because this is their pre-alpha release. Just came out on, I think, Friday. And yeah, they are saying that future releases will support additional backends, but I doubt that's going to happen anytime soon. Because the thing with these crypto companies I found is a lot of them like to they like to hire on academics to work on like programming languages because people in the crypto area seem to have found that functional programming has this killer use case as like a smart contract language, and so there's been a lot of research into these kinds of like dependently typed languages for use in smart contracts. So what they'll do is they'll pay for researchers, and they'll usually ask them exclusively to work on like some compiler backend that is, you know, compatible with like smart contracts only. So, and in the future, when they support additional backends like maybe Haskell or something, it could be used as a general purpose programming language, but for now it's probably just only going to be used for smart contracts. And I think actually Formality is in a similar boat. Like they like the Ethereum Foundation offered like we'll pay you lots of money, we'll fund your project because we know you guys need funding. However, you have to make sure that it only works for like, or you have to start with you know, compiling to EVM bytecode or whatever. You're not allowed to you know, turn it into a general purpose programming language right away. So it's kind of an interesting and a somewhat sad thing, but that's kind of that's where the money is made these days if you're doing PL research and you're in this area. So anyway, that's kind of the context of this. I'm just checking this out purely because programming language, not because I care about crypto at all or anything, or Metastate.
Just because you're interested in the latest and greatest in programming languages?
Yeah, pretty much. Just wanted to check this out. So they have a few links here. The first one was this VS Code link, so I actually have that here. I've already installed this thing. This one was pretty easy to install. What else we've got? We've got this blog post and website. These two links actually lead to the same place. They lead here. So not really sure what that's about. Seems like
a more elegant language for a more civilized age.
I know, right?
Wow. That's a bold statement.
Yeah, these crypto companies, they really like to try and sell their stuff. So kind of interesting. Don't know how true that is, especially because this is only a pre-alpha and everything too. Like they're still working on it. Like how fast is it really? They're saying that it's going to be like security critical, performance sensitive, and whatnot.
Right.
But
so this is like a new FP language that has this specific use case of smart contracts.
Yes,
basically.
At least for now. See, that's why they have this. In future, we'll have different backends. So after they're done supporting Michelson or whatever, they'll probably add like a, I don't know, maybe like a Java backend, a Haskell backend, maybe like more conventional languages will be supported. So it'll be able to compile to Java or compile to Idris or compile to Haskell, whatever. That's what this basically means. And so if it is able to do that, then you'd be able to use it as a regular programming language, just like any other.
Okay. And I know you said that you don't really care that much about crypto stuff, but like, what is a contract? A smart contract?
I have no idea.
No idea? Okay.
I have no idea, and that's kind of what I wanted to learn a little bit more about today, which is a little bit of that's another part of the reason why I wanted to take a look at this, was because I was like, I don't know what, I literally know nothing about smart contracts or whatever. This thing apparently has some resources around that. The last link here is the repo. That's this. But yeah, when you click on try it now, they actually have like a little tutorial. So that's kind of what I was looking to go through today.
Cool. This is like the hello world.
Yeah, this is the main activity for today's stream. We're gonna do a hello world and Juvix and stuff. So the first thing I need to do actually is install Juvix, and so I think in the email they even say I don't know, they said somewhere that they support Windows. I don't remember where exactly, but I did
for Windows, follow the instructions here.
Yeah, I did the Stack installation, so I have Stack. Stack is like a Haskell build tool. I don't really know the nature of Stack, really, honestly. I barely use Haskell at all. But yeah, I have that installed, and yeah, here's the result of trying to run make.
Oh boy.
Yeah. So
well,
Windows instructions, not that great. But that's my first impression of the language.
Yeah.
Yeah,
So I
great.
see you have Ubuntu, like Ubuntu on Windows open.
I
Did you have more luck
do.
doing it that way? Right.
Yes, I do. So you'll see I've also been playing around with Idris too. This is just, try installing that here. I actually have it on my other account already, so I don't know. It's just because I felt like maybe later, if things don't really work out with Juvix, we can just play around with Idris too for a bit. But anywho,
Okay. Yeah. I'm still curious about the nature of these smart contracts. I feel like if we're gonna do a Hello World thing, like it's good to say what the target is, right? Okay, this is Hello World. We're gonna print Hello World to the console. But
yeah,
with smart contract, it's like,
what's
okay, what is the endpoint? How do we know when we're done?
yeah, exactly. I'm like, I don't know what is a Hello World smart contract. So I guess we're gonna see what that is
We're gonna find out, I
when we
guess.
find
Okay,
we'll
we'll
find that out when we
discover
go
it
through the
together. Here
tutorial.
we go.
But anyway, yeah.
Right.
Windows basically out the window. Haha, no pun intended.
Okay. Ha 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 ha.
So I have WSL here. We're going to try, and we're gonna install. What
We're
is
gonna
it?
see what we can do
I
here.
think we're gonna have to install Stack here as
App
well.
install stack. Let's do it.
Oh,
Uh-oh.
permission denied. Do I have to sudo? Yeah.
Sudo app. When in doubt, sudo.
Unable to locate package Stack. Oh, that's really cool. Huh.
That's not good.
Oh.
Well, we can't go Arch Linux, and we can't go Mac OS. So,
Well, no, it says for you. It says right here for Ubuntu.
yeah. Well, I know, but it didn't work. Do we
What is
do?
it? Is it sudo apt update or what? How do you get the packages?
I thought it was like sudo apt get blah or something. Apt dash get maybe. Apt get. I can't remember the exact syntax. If there's a dash or if there's a.
I think it's.
Okay, that seems to be working.
I want to try update just
Sudo
because
apt update.
I just want
Yeah,
to update the list of packages that I can get.
sure. And then the next step will be Stack Overflow, or like the Linux Stack Exchange will probably have an answer to this question.
Oh, you're probably
This is
right.
actually, yeah,
Ugh.
this is actually quite interesting. I've never really used WSL for anything. I always kind of wondered how like package managers and that
All
kind
right.
of stuff would work. So this is quite interesting.
How do I sudo apt get something? Oh, apt dash get. You're
Why?
right. You're
Yeah.
absolutely right. What do you mean?
Okay. And now I would say just copy the line from the instructions and pop that into Google and with the error, and then there'd probably be some Stack Exchange post. And then what was the error you were getting? Just like can't find Stack or something?
What was it?
Unable to locate package Stack, right? Or
Yeah,
is
unable
that
to locate
what it
package
was?
stack. So,
Okay.
what, like this, and then like this?
Yeah, then just unable to locate package Stack,
Oh
yeah.
my God, you're teaching me how to Google properly. I've never bothered to learn.
Hey, look at, oh well, okay. I mean, this is close. Unable to locate
Uh-huh.
package. It might be a bit generic,
Oh
but
wait, this is
we
sudo
can
apt
see what
get
that one is.
install. Maybe they missed an app.
Well,
Yeah, maybe they
what's the
missed the
difference
get.
between apt and apt get? I don't know.
Nope, still can't
Unable
locate
to
that.
locate package. Okay, so the command was good, but the package wasn't there. Maybe you'll have to add like a maybe sort of like git, like you'll have to like add a repo, like add a remote or something. You'll have to add a repo so you
That's
can
what.
pull it down or something.
Yeah, that's what I'm kind of thinking. I don't know. There might be something missing here, but yeah, great. This is leaving a very good first impression for me. um.
Oh, okay. So
Oh,
yeah, you got to curl something to like what?
for common Unix
What?
operating systems, all you need to do is run curl this, I guess.
Okay.
Okay. I guess we can try that. Oh, I didn't copy the C in curl. Let me get that. Let me get this whole thing. Uh. There we go.
And okay, well let's just see what happens. Okay, and
Hey, I think.
oh, okay, this is good. Okay, doing stuff. So we'll have stack after.
Yeah, supposedly. So this is the Haskell tool
How do we know
stack.
that stack? How do we know that stack corresponds to Haskell tool stack?
Oh, because that's just the name of the command, right? Like they say stack is required. They have a link to Haskell
Oh, it
stack.org.
links to it. Okay, okay.
Yeah, that's how you know.
Right.
So yeah, I guess we're gonna have to just sit here and wait for stack to install. Great.
Wonder what is Arch Linux? Like what is that? What was the problem that Arch Linux was meant to solve? Like how is it different than other Linux flavors?
I don't know. Is it just another Linux distro? We can always look that up. Arc
Yeah, I think so.
Linux.
But like there's when somebody sits down and is like, I'm gonna make a new Linux distro, they have to have some problem they're solving, right? Like a simple lightweight. Oh boy. Okay. So
Flexible Linux issue tries to keep it simple.
okay. Like what if we Google Arch Linux versus Ubuntu?
That's a good question. For users who desire a do-it-yourself approach, Ubuntu provides a pre-configured system. Well, if Arc is
Oh,
supposed to keep it
keep it
simple, then
simple.
why is Ubuntu like
This is
the easier thing
confusing.
to use? I don't get that.
Right. Independent.
Uh,
Oh, no commercial agenda. Oh, shots fired. Okay.
whoa, wait, what? Did they just
Oh, it
say?
just said this is from the Arc Linux. It says, yeah, Arc is independent, blah blah, with no commercial agenda. Unlike Ubuntu, which is not said but heavily
Wow,
implied.
tisk.
Okay, did that work? I saw a
It
warning, but I don't see
kinda
any
did.
errors.
Okay, so installed to
It's
here.
not in your
Okay.
path. Okay.
I have to add this to my path, I guess. Let's do that right
How
now.
come it's saying your local bin is not, but it was installed to user local bin, and it's
Yeah.
saying home recording local bin. Okay, maybe that's an alias or something.
Oh.
Sure.
Okay, maybe this is.
Stack will place the binaries it builds in home recording local bin for
Yeah.
best results. Please add it to the beginning of your path. Okay.
Yeah, I think that's
Well, let's do
some.
that then.
This is some WSL shenanigans. Let's do this. Whoa. This looks crazy. It didn't look like this yesterday
Yes.
when I was looking at this.
Oh, maybe something's been monkeying with your path or your profile. Uh, okay, so you just gotta pop that in there and
Oh wait, how do I paste? Like this? Okay. Does that work?
and did
No, that doesn't work, right?
well it said add it to the beginning of your path. So you got to be like path equals, or you could just do it. Don't
No,
you
it
just
doesn't.
do it like it's like path export path? No, export. We'll just do it for your current shell session. I guess you want it to be persistent. It's very confusing.
Yeah, no. Oh
I
wait,
think
no.
you're on the
Home
right
is
track.
home/recording. That's what that is already. I don't need that.
Okay.
Uh, so I can just use $home for that. I think it should work.
Yeah, you could just like copy that path and then just like echo it and make sure it's reasonable as well. It's a sanity check. I
Uh,
can't really see the
Me neither. This
the
is
the
this is
color scheme.
terrible.
Yeah.
These are the default colors though.
Okay.
Oh my god, it split it again.
Whoa.
I wasn't expecting that. Okay, please go away, other window. Because usually I have to do a manual split when I'm in NeoVim, but anyway. Echo path. Ah, it's kind of huge.
Whoa, is it in there?
Yeah, here it is. Home, the slash home slash
Okay,
recording is there. So
sweet.
yeah,
Okay,
Idris2 slash bin. So home recording is our home variable. I can even echo just home. Yeah, slash home slash recording.
sweet.
And oops, I need to switch windows. There we go. So yeah, I'm just gonna use that instead. How do you
Okay.
separate entries though?
This is a good question. I would have to ask Stack Overflow for that to be certain. What is the delimiter? I don't know. Space would be my guess, or commas, or something, but I don't
Uh,
know.
I don't know. It looks like it might be colon. Yeah,
Colons.
yeah. It's got to be
Wow.
it's got to be a colon. That's got to be it because there's a colon right before the home here too, like after this path. I think it's got to be colon. We're gonna try that.
Okay,
Doesn't this seem fun?
and then you gotta source your bash profile, right? Get that changes reflected.
Oh, I actually forgot how
I
you do
think.
that. Source
Uh,
this?
just literally source and then your profile,
Yeah, there we go.
like the profile file,
Yeah, yeah,
and then
yeah.
that should.
I'm still a Linux noob.
Me too. I know just enough to get by.
Yeah, pretty much. I just learn it as I go along on the job.
Pretty much.
All right, we sourced the thingy. So that's probably good. We can probably run stack now. Yeah, there we go. It recognizes stack. Looks pretty
Sweet.
good.
All right.
All right, so now
So we got stack.
we go into the Juvix directory. There's nothing in here. Um, let's try cloning the repo. Yeah.
Cool.
So their repo name changed recently, actually, or at least like this username changed. It used to be Metastate Dev. So the link in the newsletter points me to this Heliax Dev thing instead. So I don't know if it's the same. Hopefully it'll be fine. That's the one they point you to. That's the user experience if you haven't found the repo on your own. So I mean,
This feels very alpha indeed,
yeah, it is.
but we'll see how far we get.
Git clone blip. Yeah, if we don't get very far, like if this explodes and dies when I try to make, then I think I'm gonna just move on to playing around with Idris for a bit, and we'll have to try and play with this maybe at a later date when they, fix their stuff.
Once it's not quite as rough, sure.
Yeah. And we've got our Juvix directory, so we go in there, and now we run make. And in theory, everything should be completely fine.
Yeah, just hanging out with Jonathan too. Oh yeah, I will do later.
You hanging with someone?
Oh, that's Yanji, my wife.
Okay.
Yeah. Do you want to make it soon, sweetie? I don't know, we're just trying to figure something out here. Probably how long do you think it will take to Juvix it up here?
I don't know. It depends on how long the install is. Maybe we should have like
Right.
a hard cutoff then.
Sure.
If you've
How
got to
about
go
you
for
want to do it at
something,
2 o'clock, sweetie?
yeah, we can do
Okay.
2 o'clock.
All right. Let's see how far we can get.
Yeah.
What are we downloading? Is it still the Git repo? No, we have that already.
No, we have the Git
Oh, we're
repo.
making it. We're building it.
Yeah, we're
Excitement.
building.
Whoa.
This is the
Wait,
moment of
it's
truth.
downloading something. Okay, interesting.
Yeah.
Guess it's getting dependencies.
GHC info. Yeah. So
GHC Tinfo, whatever the heck that is.
GHC stands for Glasgow Haskell compiler. So it's doing some Haskell stuff right now. It's unpackaging.
Interesting. So there's a sneaky. So Haskell is involved somehow. Interesting.
Yeah, I think
Right.
they actually wrote this entire language in Haskell, if I remember correctly. Do you know what happened to the little bar at the top that shows like what percentage of the code base? Oh no, here it is. They moved it onto the side. Yeah, see, it's 85%
interesting.
Haskell.
That's cool. That's a cool little bar there. I didn't know that existed.
Yeah, it's every language has their own like unique color. It's kind of cool. You can see like what percentage of every GitHub project is like a certain programming language, and they also include like HTML.
Right. Yeah. That's neat.
Yeah. They have a bit of Idris too in Agda. I wonder why. F star.
Yeah. A
Common
lot of
Lisp.
weird. Common list.
And a tiny
Okay.
bit of TypeScript. Surprisingly, even less than other.
Other.
Yeah, other. I guess that's sort of like
The
custom
mysterious other.
stuff, or like like these lock files, YAML files,
Oh yeah.
readme.md. That
Oh
probably
yeah.
falls under
Yeah.
other.
Probably would be the YAML stuff.
License file.
Good old YAML.
Or if this just takes too long, then oh well. we'll just end
Okay.
stream anyway at 2. I don't really care.
We'll we'll figure out how.
Configuring GHC.
We'll see how far we can get. Yeah.
Oh.
Like how big is this project when you downloaded it? It's not like super big, right? So it probably won't take that long.
I mean, it says so right
I think-
here, right? Receiving objects
Yeah.
100%, 3.71.
So like it'll probably just take a long time just this once because you got to get all the dependencies.
Yeah.
cache those things, so it should be faster in the future. We could take this time to figure out what a smart contract is.
Yeah, that's a good idea. Let's poke around their stuff. So yeah, installing.
Installing, okay.
Writing your first contract. Copy the following to a file named identity.ju. So that's their
Okay.
file extension .ju. So they've got prelude Mickelson sig
Whoa.
cons pair. Okay, so this looks like a function signature. Oh, my mouse just froze. Whoa, whoa.
So,
okay.
uh-oh. So it takes an int and a pair, or returns a pair, or this is confusing.
Okay, so the way that this reads in Haskell normally is that all arrows or all arguments before the last arrow can be read as the arguments, and this is the return type, the thing that comes after the last arrow.
Okay, so returns a pair of list operation of type int. Whoa, there's so many types.
No, it's returning a tuple of a list of operations.
I see.
And so that's on the left side of the tuple, and on the right side of the tuple is an int. So it's returning a pair of.
Oh, okay. So it's like it's a pair, and the pair is going to be it's a tuple. The left. Okay, gotcha.
So that's interesting. So it takes a
list
of
operations.
Like a
signature.
Yeah, it takes a list of operations as an argument. It takes an integer, and then it returns both a list of operations and an integer. So it doesn't seem like it does anything. Yeah. And then
so where's the actual like implementation of that? Is this
the implementation. Yeah, that's the signature. This is the implementation. Okay. So this is interesting. They start with a let, and then they write cons pair. So that's the name of the function. Let cons pair equal. And I'm guessing this is just a constructor for a tuple. And I guess they implicitly they do that they do this functional thing where you don't have to explicitly list out the arguments. And
just like a wrapper to convert it into a Michelson pair.
Yeah, that's basically all this is. This is just like the constructor. It's weird though that they have this little percentage in front. That's interesting.
Wonder why they couldn't just directly instantiate a Michelson pair.
I don't know. I don't know. I don't know what this Michelson stuff is for anyway. Like, why is it?
Well, anyway, okay. So clear enough.
Let's see, how's this thing doing?
Takes a list of operations and an int, returns a pair. Okay.
This thing is
still installing GH.
My computer. Ooh, yeah, that's lag. I don't know what's going on. What the heck are they using my machine to mine bitcoins like right now or something?
Is compiling your computer.
Help! Help!
It's just taking up all of your CPU power to mine bitcoins and send it to the freaking Juvix lords.
What is this? What is happening? Man. That's so weird.
Okay,
hey, look!
Well, what's the next thing here? So
we've got main. Sorry,
I
jumped ahead. We got main.
Nice. Okay, we got public static void main. Sweet.
The main doesn't return void though; it returns a pair.
Oh, okay.
Weird. Oh, this must be like.
It takes a pair that's an int.
Yeah, my computer's chugging.
A pair of integers and returns a pair, list of operations and integer. Okay. Cons pair nil. Oh, cons pair. Isn't that's the function that we defined above. So we're passing a nil as the operation, and for the int, what is car params? I guess that's like the parameters we.
So there's
a
function called nil, and there's a function called car.
So car is another function which takes.
It takes two integers, and then it returns an
a Michelson car, but it doesn't do anything with the. But it doesn't do anything with the It doesn't do anything with the integers that we pass it.
I'm.
Unless I'm missing something.
I'm not sure what this is. Yeah, car. What is car? That's not explained particularly well, I would say. Alright, so this is the bottom of the page. Then run Juvix compile identity.ju identity.tz. And then
it should look like. Wait, is there anything in that box?
There's nothing in this box.
Pre-alpha.
That's pretty great. Pre-alpha. Remember, it is pre-alpha.
Okay. Okay.
Very pre-alpha. This thing is taking forever. Holy cow! We're not. This
Still
thing is not.
going.
I have a feeling this thing is not going to finish. We're not going to be able to have time to even try this out.
Okay. Well, we can just like read through this thing, try to
Yeah.
figure out what it's doing.
Okay, and then deploying the contract to Tezos. So I have no idea what Tezos is.
Don't know what Tezos is. Okay.
The TZ
Michelson
Michelson
output.
Oh, that must be the output file name. Okay.
Right.
The output of Juvix can be deployed using standard procedures outlined in the Tezos documentation. Direct integration with the Juvix
Interesting.
is
Okay.
coming soon. Okay.
So I guess identity.tz is supposed to be a bunch of Michelson code.
Yeah, I would guess so.
Like when it says,
All right, we're gonna move on to the programming and example. Oh. My mouse cursors. Yeah, okay, I've got control of my mouse cursor.
Professional. Nice.
Looks
But yeah, their documentation is certainly pretty rough.
So here it looks like they have a tree type that they're defining. So this is a
and so how do I read that branch?
This is a recursive data type. So there's 3 different constructors for it. Empty is obviously like an empty node. Leaf is I guess a leaf node. Branch seems to have a left subtree, a right subtree, and some value.
Okay. Or is it saying branch is of type? Oh wait, no, it's not.
No.
Tree A. Oh.
Yeah, this is these are 3 different constructors for one data type tree.
Sure.
You can think of it kind of like an enum.
I guess that makes sense.
You kind of think of it as like a more powerful Java enum. Like it has.
Okay.
Like these would be the different variants. Like you could have it be defined as like days, and this would be like Sunday, Monday, Tuesday, Wednesday, etc. But instead it's branch or
well,
leaf
they're constructors.
or empty.
Right.
So,
well, that's all you need to build a tree. So there you go. Cool.
Yeah. Pretty simple looking.
And what does that say? Okay.
All right. So here's a function signature. Okay. So here's, so they're taking a tree. So this is a function named func. Great name. And this argument is named foo. So this tree of natural numbers is called foo. And what they're gonna do is they're gonna compare it. They're gonna check to see what kind of tree it is. So if it's a branch, then it'll do this. It'll recursively call func on the left subtree, recursively call func on the right subtree, and add those results to the element in the middle at the current position.
So where's element coming from?
It's part of the constructor. It's this middle element for branch.
Oh, I see. Okay.
Yeah, because at the current node that you're in the tree, like if you're at the root of the tree, then maybe the root of the tree is like 2, right? This would be 2.
Right. You mean the value itself?
Yeah, the value itself is 2, and then there's 2 subtrees. There's a left subtree and a right subtree.
Right. Okay.
And so yeah, they do the same thing with the leaf. For the leaf they just return the element. So if the left subtree with our root of 2 is like 1, then this would go down to leaf and say, okay, return a 1.
Right. Yeah, a leaf is the leaf, so just return the elements, and then if it's empty, then there's nothing.
Return 0. So this returns
a natural number. That would be where you would return null, but because it's functional programming, we're not allowed to do that. It's 0.
Well, it's because this is actually this has to return a natural number. It's not going to return null. It's going to remember it's doing addition. It's adding. So I guess what this func is doing is it's just summing up
all the elements.
Yep, summing up all the elements in the tree. That's exactly what it's doing.
Cool.
What does this have to do with smart contracts?
This is a good question. Well, we still don't know what a smart contract is, so it could be totally irrelevant.
Yeah, I don't know. Skipping ahead.
What else are we doing here?
There's another function here. I don't really care. Oh, this is the same function. Okay, so this is a different syntax that you can write it in.
Oh, I see. Okay.
Weird. This one that
looks a little bit more familiar.
This is a little strange because they don't have a function signature. You notice they don't define func2 anywhere?
That's true.
So I'm guessing
Or is it
that
saying so func2 takes a branch, an element, and oh, oh
yeah,
no, this is
it's the
kind of
same as
confusing.
this. These three definitions of func2 are the same as this case where they check if foo is a branch or a leaf or an empty.
Right. Okay.
So this thing implicitly knows what signature func2 should have. You don't have to explicitly say what it is. That's interesting. Here's a definition of what is essentially a struct. So
Yeah, that's
field
fair
x
enough.
has type int, field y has type int. Nothing special about that. Okay, so here's something interesting. You can put question marks in the names of your functions. So this one's a predicate. It returns a boolean. What is this doing? So this... Oh, okay, so this is using like some sort of destructuring syntax. So you can take an object of type chords, and you can instantly reach the fields of it without having to go like
Unpack it. Right.
chords.x or chords.y. So yeah, this kind of
Right.
unpacks everything. And this just checks if x and y are both 0, return true, otherwise return false.
Huh. It's an interesting conditional syntax. It's just like one single bar. That's basically saying like if.
Oh yeah, that's I didn't even notice that. You're right. That is weird. Yeah, they don't even use this case of thing. So like here they're using case of. This just it does like a bar.
Yeah, so you're just like, I don't
That's
want to
just
type
true.
if, so let's say it's bar.
Yeah.
Although bar really makes it sound like or to me, like some sort of like an or comparison. But anyway, I guess you get used to
Well, I
it.
mean, it kind of is either this case or it's this case, right? Sort of.
Yeah, well, yeah, that's true. Yeah,
So they use the keyword else to indicate like for anything else that doesn't match this, go to this case. So
right.
I think that seems fairly standard. And here's the same function again, but it looks a little bit different this time. Oh, okay, so they named their parameter. So that you can, instead of having to go with x and y, you can use org x and org y instead. And this is basically the same
Sure.
as this. And I guess
Sounds
true
good.
can be put on a separate line underneath. I guess that's interesting, but not super important. They've got a proofwriting guide as well. I don't know if... oh, whoa, this is not what I thought it
Oh
was going to
boy.
be. The essence of which. Okay.
Wow.
Modify software
Syntax
verification.
guide. Oh,
Proofwriting less of a burden on you, the user. Currently, only specialists and a few others can write proofs for their programs. Is this thing done? My mouse is surprisingly okay. No, it's
oh,
not
look
done.
at it go. It's doing stuff.
Yeah, it's doing stuff. It's going now.
What's it
Yeah,
doing? It's compiling stuff. Okay, so you got your compiler set up apparently. It
cool.
must just be compiling all the sources you pulled down.
Yeah.
Uh,
I doubt we're going to
okay,
be
well,
finished
that's
before
good.
2, though.
We got 2 minutes.
We've got 2 minutes.
Uh-oh, fail.
We've got 2 minutes to read about writing proofs in Juvix. Currently, only
What can we
specialists
glean in
and
2 minutes?
a few others can write proofs for their programs. Uh-huh.
I would say that that is true. Yeah, it's not exactly a common skill.
Our hypothesis is that programmers are well equipped to derive and prove properties of the software they write, but they lack the mathematical maturity and vocabulary to carry out a formal proof. Uh-huh.
Yeah, sounds about right for me.
Students fail to produce
I
well-meant
lack
proofs
mathematical maturity.
due to lack of mathematical maturity. Okay. Even though they understand the subject matter at hand. We believe that program verification doesn't have to be like this. And we did something about it, really.
Oh, wow. Good
We
for them.
created an assistant tool for theorem provers that puts together many different strategies for proof automation. Specification for such an assistant for Juvix uses algebraic effects and handlers as the means of congregation. Did that make sense to you?
Not really.
Okay, me neither. The approach to facilitate program verification in Juvix is named Witch, a play on the name of assistant tools colloquially called wizards. There is no consensus of what a wizard is, or what the exact tasks it is supposed to assist with. Okay. Wizards seem to be used mostly for multi-step and or configuration features, however. We went for the name which to align it to the idea of assistant tools while dodging the overloaded and confusing terminology. Alright. We provide effects and handlers view of such proofs based on prior work developed on the Andromeda prover. I don't want to go there. In Juvix, you program as you would normally and invoke the proof environment as an effect to prove certain properties as you go. Even though the proof environment is just an effect, different proof styles, IO-style dependent types, SMT solver, proof search, can be composed under a shared interface, a proof object that can manipulate itself while querying different automated provers. Okay, so it sounds to me like it lets you switch between different modes of proof style. Okay, they talk about why they employ algebraic effects and handlers. I'm not going to read that. I don't really care.
How does it like? Okay, we're now into like negative time, but let's see how. I'm curious how this proof works. Like, can you
I
make
don't.
heads or tails of that? Like, what are they trying to prove?
Okay. Well, for the syntax, we use operation params via handler, which is semantically equivalent to, but syntactic improvement over handler operation params. This effect handling is similar to a function application, but also carries the effect. I don't know much about effects, so this is kind of like gibberish to me, but the user defines data types and functions as usual, and then uses which to
Okay,
prove
well,
properties about
to
set
me as well.
definitions. The examples will show it in action. So this defines a data type called n, which I presume stands for natural number because they define a 0 and a successor as the two constructors for it. So this is similar to that other syntax we saw, except it just looks a bit different. So it's either a 0 or it's a successor, which takes a natural number and returns a natural number. They've defined addition here, so that's just how to add numbers.
So it takes two natural numbers and returns a natural number.
Oh, okay. So here's a function name plus com. So this is a proof of commutativity of addition, and this just says for all x and y that are natural numbers. I don't know. I guess which is something we can ignore. X plus y is equal to y plus x. So this is just a proof that, yeah, addition is commutative.
It's equivalent or something.
So x and y are two arguments of type natural number. So these are the two arguments, 0. So this is doing a kind of a case of, like we saw earlier, where it checks like if it is a 0, do this thing. If it is a successor, do the other thing. So they're basically doing a pattern match here. And I don't know what this is. Tactic 0 plus y equals y plus 0 via
ring. What's the via ring proof?
I don't know what via does. Okay. And so, I know what a ring is. I know what a ring is from mathematics. It's like, well, I don't actually know what a ring is, but I have an idea of what it is. It's sort of like a group in like group theory, that kind of stuff. Abstract algebra stuff. And they have search.
This is true. And then we get more complicated. We say for two numbers of search, x plus sy equals
the successor of x plus y. Yeah, that's true. Like if you add 1 to y,
via backtracking,
it's the same thing as adding 1 to x plus y, right? That's what that says. But I don't know what via backtracking is for here. So this is obviously our inductive case, right? Like this top case is our base case. And so this is the case for doing induction. Usually you'd do this with recursion. I don't see any recursion here at all. So that's kind of interesting. Yeah, that's weird. That looks very different from what I'm used to. But I'm only used to doing theorems in Idris, so I've never seen this kind of style of theorem. And this one looks like, honestly, okay, these are lists. That's what this square bracket syntax is for. That's the same as in Haskell. So Haskell has a syntax where you wrap your type in brackets, and now it's a list of that. So we have 3 lists, and plus plus is the append operation. So we're appending the lists. And what this theorem says is that for all lists x, y, and z, I guess a of type set. Basically, this is a type parameter. So yeah, this is you
Well,
can think
list
of
of
this as
set.
lists of
Okay.
A. Um, X append to Y, and then appended to Z is the same as X appended to uh, Y is appended to Z's. That seems wrong. That's a typo. That's definitely a typo. This is wrong because these variables don't even exist, right? Like the only variables defined are A, which is a type parameter, and X, Y, and Z. So Y's and Z's should be Y and Z, not Y's and Z's. And yeah, same thing here. They do this via
Makes
thing.
sense.
They use a SMT solver instead for this. So this is the base case again, and this is the inductive case. But this one uses rewrites. Yeah, that's weird. And the equals for this case is way down here. So yeah, this is all part of the, like, all this stuff is part of the arguments list. So that's kind of interesting. That's not really very readable, as far as I can tell. And here they talk a little bit more about that. I don't know. This seems a little bit strange. Can we go back to the home?
The proof
Sorry, were you saying
search.
something?
Right, proof search. Okay. Oh yeah, just like the proof search thing that they were talking about. It seems like there's some sort of like automation going on there. But I think I'm gonna have to drop
Yeah.
off. I'm just checking to speak.
All right, sounds good. I'm gonna check out the VOD and see how that turned out after this. And yeah, that was cool. That was fun.
Cool. All right. Well, it was fun. Yeah. All right. And things are sounding great. I think your streaming's good to go.
Yeah, awesome. I'll
Cool.
talk to you later.
All right. Well, I'll talk to you next time then. Yeah, sounds good. Okay. See ya.
Bye.